So before we start our live demo, let's just talk a little bit of application observability. We're going to go through the solution and then how to quickly and effectively troubleshoot using our capabilities around service map, traces, and spans and logs as well. And then we'll wrap up with global intelligence and taking Kubernetes as an example of how Sumo Logic can help you benchmark and really optimize your deployments. First, what we're hearing from other customers is that they have this expanding tech stack with an exploding number of components and the rapid rate of change, which is really causing a deluge of data as far as machine telemetry that's being generated. And they're seeing that keeping all of these tools siloed, it's really they cannot keep up with this change in the paradigm of how their applications are being used. And as we look at observability, that allows us to be able to now troubleshoot and monitor these new application. It's not just about the telemetry that we're collecting. It's about the rich analytics of how you make use of those data to be able to go from monitor to diagnose what the problem is, and then troubleshoot by using this rich data set of logs and traces that really get to the root cause in a very quick way. Whereas in the past, with the large amount of data that these systems are generating, it becomes impossible for a human to then be able to sort manually through all of this information. And that's why we need this richer analytics platform to handle it. And Sumo Logic really provides that. You're able to get in data and machine telemetry from both of your on-prem, cloud, DevOps tool chains, all of these different aspects of your application stack into a single platform with a single unified analytics engine that allows you to work through all of your metrics, your traces, your logs in one system to then be able to actually connect them and make a better sense of how one area of the system is interacting with another, and then map all of your different microservices. And we'll see that as we go through our live demo. So before we jump in, Sumo Logic Observability, we are really passionate about building it for the observer. We want to be able to create out-of-the-box dashboards and alerts to really cut down the amount of time it takes you to set up and get working. And we understand that depending on all of the application components and the infrastructure, it's really beneficial to get out-of-the-box information so that you can quickly start getting value from the system. Using our rich metadata enrichment, we're then able to see those dependencies that accelerate the investigation. So you can go from the microservice of the application to the infrastructure underlying and be able to connect all of these as you're troubleshooting when things just go awry. I did talk about applied analytics, and this is how we are able to surface these unknowns of when the application is not behaving the way that you expect it to, by having this unified search across logs and traces, as well as ML-powered capabilities like our brand new alert response page that really surfaces changes in the signals that have been observed while the problem has been happening, as well as our root cause explorer that allows you to cluster all of the erroneous or anomalous events into a single view so that you can look at what errors might be causing other areas of the application to fail. And then our benchmarking and optimization. We're continuously updating our ability and being able to grab these golden signals and then benchmark across all of the different deployments. Given that Sumo Logic is a multi-tenant system, we have visibility anonymized across all of the different deployments that allows us to apply these analytics and then tell you whether a Kubernetes cluster is over permissioned, under provisioned, and what recommendations the system provides so that you can set those memory and CPU thresholds for all of your Kubernetes deployments. And we also do the same around Apache Nginx, looking at traffic and traffic shaping errors, etc. All of those come as part of the observability system. So let's just now talk about our live demo and where we're going to go explore. So we're going to look at this demo app, Sumo Coffee system, where we have a front-end application with app components like DynamoDB. Our platform technology is running Kubernetes, Lambda, EC2, and it's all going to see is running in AWS. So we have our front end that you can, the customer goes and orders coffee, and then in the back end, we have all these microservices that provide all of the necessary mechanisms to be able to fulfill that order. So let's go and look at the application itself. So here we have our coffee bar app. We can see the health across the latency of the service. We have our different application details, all of the services and how they're performing, as well as the latency and requests that we're seeing in the application. As we move down into our front end, we can see our latency, our errors, and then moving into our real user monitoring side of things, we can look at a specific action and look at page load time requests, and then some demographics around where is this being accessed from, what browsers, what operating systems, geolocations, etc. And here we see that there's been a spike in the front end of the system. We're tracking all of the different front end response times, from time to process, time to interactive, UI painting time as well. And we're able to see all of this in our system. So if we wanted to investigate this specific spike, we can go in to see the entities of the action within the service and within the application. But what I want to do now is go look at the interdependencies of this application. So I'm going to go and look at our coffee bar, and we can see all of the different microservices, how they're really interacting with each other. We also have our Lambda functions as well as part of this entire system, so that we know that when we do a front end request, we go into the coffee service that then has a cache desk, and then the actual coffee machine itself. Here we see that there's some red, which is really highlighting that there's anomalies. I can go into the specific coffee machine itself to look at the service and the application, and then go into the actual machine itself to then be able to look at all of this information. Since I know that this is having some issues, I can then go and open up all the different traces that are associated with that machine service. Here I can see some of them that have high error rates. If I wanted to filter that out, I can just go number of errors larger than 5, for example, and then filter those out using the system. Coming into one of these traces, I can go in for the root operation of click, and now I can see everything that was happening within the system itself. And I can just check error spans only, so I can see where the problem might have happened. So here we have in our coffee bar service that the prepared coffee was maybe having some issues. If I click on this span, I get a lot more information as well that helps me troubleshoot. One of the really great things is that since our query language can create the schema on demand, you can just query, open up all of the logs that are associated with this specific trace ID, so you can see all of the information that happened when this entire transaction was kicked off. We're able to see the metadata for this specific span, prepare coffee, and then we can see entities. And this is really cool because not only can we see the operation, but we can see the infrastructure that was happening behind it. So it may be that it's not just that specific trace. Maybe there's a problem with the pod or the container. So I can actually go into the pod itself that served this specific transaction and then just open up all of the logs for it. And this allows us to then be able to start doing additional troubleshooting to see if it's something that's happening with the pod, Right now, there's only 39 results. There's not a lot, but this can explode to thousands of results, which is where our applied analytics comes into play. We're able to click this log reduce that looks at all of the different signals and starts doing pattern recognition in real time, so that these signals are then distilled into the ones that you might be most interested in. And as the results come back, then I can actually start seeing what other areas happened here with the different signatures. If I go back, then I can go and see all of the different info, etc., for this specific pod, to then be able to see exactly what was happening. The other way that I mentioned that we could get to this information is to then just go and give me all of the traces for this specific trace ID that had an error, and then I can go and see everything that was happening. And here we have the error for this specific transaction where the coffee ran out of coffee grains. So that's why it could not fulfill that order and created that error. So there's multiple ways of getting to the information that you need to really do the troubleshooting. And as you can see here, I'm just searching the entire data set for this specific string, and it automatically is able to extract that out, look for it in the information, the unstructured log data that we have, and then be able to retrieve all of the different signals and information to give you a quick view of like, oh, I failed because I didn't have coffee grinds. Maybe I need to go back to the machine, fill out my coffee grinds, and then the system will recover itself. I know it's a simplistic way of doing things, but it also happens with database running out of connections, the payment services, the API is not working. All of this can be really highlighted by using the metrics to detect that something was wrong, traces to figure out what part of the system that is interconnected really had that problem, and then pulling out all of the logs to be able to get to the root cause in a very easy flow by tying in both the application and the infrastructure that's running this. And as you manage larger and larger systems, managing this infrastructure, it becomes a challenge, especially as you're doing maybe multi-cloud, multiple geographies, multiple accounts. And we're able to help our customers really take control and look at how they can manage all of their different systems. So instead of taking an application-centric view, I can take an infrastructure-centric view and look at for example, our production system in US East. So now I have all of my different AWS services that are running in US East, and I'm able to get a bird's eye view of all of the things that are happening with my infrastructure, my Lambda invocations, how my RDS is doing, how the Dynamo DB requests, what are happening. And I can either dive into a specific area like Lambda and see what problems and what errors I'm seeing for the specific invocations. For example, here I have my billing info that has a lot of errors, and like it's always failing in this case. And then I can go in and just focus on that specific transaction itself and look at, okay, my main error is that authentication's invalid credentials. So somebody changed something and I was able to do that. But as I mentioned before, one of the big powerful things that Sumo can do is apply analytics and look at the different events of interest in a specific region in this example. So I can go in and look at my events of interest and start loading and see if I'm having throughput, errors, bottlenecks, latency, all of these golden signals that are deviating from normal, you're able to then to map out. And here we have this tool called Root Cause Explorer that I can open it up, and I'm able to filter out just for the specific account and region, and then ask the system to tell me what are the signals that are out of bounds for what I'm used to observing, to then be able to cluster them and see which errors or which bottlenecks are leading to the problems downstream for the infrastructure. So here it's going, grabbing the last 24 hours. I'm able to also add information around like my Kubernetes or application services if I wanted to add additional dimensions into this. And you can turn those on and have them visible in this specific view. Let me see if I can, oh, there we go. So here I can see the different like Dynamo table an EC2 bottleneck that then leads to the application load balancer error. And you're able to see all of the contributing entities so that you can then go in, and I think my laptop is a little bit on the slow side. So you can see all of the different clusters of errors that are happening, and then be able to see how they might be interconnected when you look at that information. So now we have this metrics. I can go in to see that the bottleneck throttle. I can then look at the specific entities of the specific table. I can look at the specific DynamoDB, and then I can open this in the entity dashboard and then just look at what was happening with my DynamoDB. What are the different table events? I see that I have some update table. I can then look at the logs for this to see what different changes happen. So I can look at each one of the logs for this specific update table event name to then look at if somebody changed the provisioning, changed a part of this deployment. So there's multiple ways and there's multiple dimensions. And since we create this entity model, you can approach problems from the infrastructure view, from the application view, and everything is in one single place to allow you for that quick troubleshooting and resolution. So now I'm just going to go back and talk about optimization and how we can use global intelligence to do that. So when we look at global intelligence, I'm going to take Kubernetes as an example here. This is, for example, an example app. We have like our payment service container. You have your limits, you have your requests, and you can see that it's over provisioned, or you can have a payment service that's under provision where your limits requests are exceeding. And when we looked at all of our deployments, we saw that around 80 to 86% of deployments are not optimized correctly. Some around memory, the others for containers. And as you can see, you need to set these 4 parameters every time you're doing these deployments, and managing all of this manually can get really really tedious. So what we've done is being able to look at how historically your pods in your application is behaving, and then be able to extrapolate based on all of the other deployments that we had. What would it look like if you optimize for reliability, optimize for cost, or have a balanced deployment within them? So with our global intelligence for Kubernetes, we do an analysis of 8 days trending, and we've profiled over 17 million containers since November of 2020. And that's how we're able to then be able to do all of these recommendations, tell you what your risk percentage is, and then how it would look like if you do a balanced deployment versus a reliability optimized deployment, so you can make decisions on, do I want to spend more on compute time and have much more reliability on that, or if it's not such a critical system, maybe go more cost optimized, but still making that conscious decision of what risk are you really comfortable taking on. With that, I thank you for joining. I'm more than happy to answer any questions. So I'm going to stop sharing for a second so I can look at our questions in the Q&A section. Okay, so one question is around the entity model and how it's generated. So as you saw in the diagram, as everything comes into the Sumo Logic platform, every piece of information is tagged with metadata so that we know the source and we know where it's coming from. And we use the Kubernetes tools as well to then be able to create that model. And all of that enriched data is then stored within the Sumo Logic platform that allows us to create those visualizations and tie that specific trace to the pod and the container that was running in, because we've tagged all of this information from either Kubernetes or EKS or all other services to then be able to bring it all together. Okay, any additional questions from the group? Great. Well, if you're, so how can you optimize the ingestion of the logs? With this increase in microservices coming up, we see a large ramp in costs. Yes, so that's an area that we've taken very seriously in the way that we are able to manage this ingestion. So the Sumo Logic has created multiple different tiers we call continuous, and that's all the logs that you need for alerting, real-time dashboards, and all of those things. And then we have frequent and infrequent tiers that are cents on the gigabyte for ingesting those. So if you're having access logs or logs that you're not really using all of the time, they can be ingested at the lower level. The great thing about our architecture is that they're not stored somewhere else. Like we don't have to rehydrate them and put them back in. They're always there and they're available and they're able to be searched at the same speed. And you can also do cross-tier search. So you can search across all the different tiers if you're really trying to paint a whole picture. So we've really taken advantage of the cloud economics because Sumo Logic is 100% SaaS, cloud-based, multi-tenant, and be able to pass on those savings. So as we see the large explosion in telemetry, we've done that to be able to manage those costs for our customers. As well as, since our metrics also go into the same store, we don't have this concept of custom metrics and high cardinality. We treat everything the same. So a metric is a metric is a metric. So you're not really limited by, we try to not limit you by cost as to which data you're going to ingest and which one you're going to leave behind. We make it very, very cost effective to bring everything in and then decide when you're going to access what. And that's how the pricing structure works. Which license tier does this apply? So we sell a single license, it's credits, and then you can use credits depending on if you're using continuous logs, infrequent logs. The logs that you saw right now were being stored in continuous, but the queries are the same. The language is the same. You just select the tier that you want to query, or you can select all tiers, and all the information comes in. So for the demo itself, everything's being ingested into continuous since it's such a small deployment. But our larger customers do have multiple tiers, and you use the same credit to be able to ingest traces, metrics, logs in whatever tier you need to. And then do I have to do anything on my end? So it depends. If you're doing on-prem, we have an on-prem collector that you install to collect all of the logs. If you're in AWS, then just CloudWatch metrics, you just point or use Kinesis to get that information right into the Sumo Logic platform. All of our apps and integrations are listed on the site, and we do either like a CloudFormation template or Terraform, and then you are able to deploy all of this if you're running in the cloud. So there's multiple ways of getting the information in. Cloud, obviously, it's like just cloud to cloud connection, and the data is there. For on-prem, we have our hosted collector, and we're working on open telemetry as well to integrate all of that information in. So you have an open telemetry agent that will be able to ingest all of these things from either your cloud, your on-prem, etc. And it's in preview beta right now if you're interested in testing out our open telemetry distro. Are there any best practices for data tiering? We do have them, and our SEs and customer success managers work with our customers to make sure that you're creating a plan around what are the best practices for your different tiering to get the most out of your Sumo Logic service. And then from my opinion, like a best practice for managing these large complex applications is to have everything in one system that can apply analytics across all the different telemetry, so that you're not having one system looking at logs and then another system looking at traces, another system looking at metrics, and then trying to correlate those things together. Because there's real power in looking at all of your telemetry across this with the same analytics engine, so you're not trying to look through peepholes across different siloed stores. Awesome. So there's more information in our blogs. Our PMs love to write, so and they're really the brains behind all of this. If you want to learn more, you can also join our public Slack channel, and where all our PMs and engineers are there. If you need to ask questions, and then we have a free tier. So if you just want to play around with it, just go up, sign up for a trial. And you can use all of our different tools and sort of kick the tires, if you will. Well, thank you very much. I appreciate all of the questions, and it was great talking to you today. And hopefully you'll join us in the conversation in our Slack or with our free trial. Thanks, everyone.